Okay, welcome back everyone. In the previous video, we discussed what is linear programming. We also discussed what does a linear programming model look like. And then finally, we also discussed the basic components of a linear programming model. Now in this video, we will discuss our first example of solving linear programming into variables. So let's start. So for our first example, it reads, a store sells two types of toys. We have dolls and toy cars. The store owner pays $8 and $14 for each one unit of doll and car respectively. One doll yields a profit of $2 while a toy car yields a profit of $3. The store owner estimates that no more than 2,000 toys will be sold every month, and he does not plan to invest more than $20,000 in inventory of these toys. How many units of each type of toys should be stocked in order to maximize his monthly total profit? So for our first goal, we will transform this word problem into a linear programming model. So to do that, we start by deciding our variables. Or in other words, we will set our decision variables. Now for the first line, a store sells two types of toys, dolls and toy cars. So in this case, we can set our decision variables as x and y. We will let x be the number of dolls and we will let y be the number of toy cars. Now these variables can be interchanged. Okay, next, we will now set our objective function. Okay, notice that the objective is to maximize his monthly total profit. Now, according to this line, one doll yields a profit of $2, while a toy car yields a profit of $3. If there are X dolls and each doll yields $2 in profit, and there are Y toy cars and each car yields a profit of $3. So how do we represent the total profit in that case? So in our word problem, the objective function is to maximize the profit. So in this case, you have max 2x plus 3y. Okay, 2x because you have 2 profit for each doll and then there are x dolls. On the other hand, we have 3y because each toy car yields a profit of $3 and there are y toy cars. So that's it for our objective function. Now finally, we will determine the constraints. So for our constraints, let's take a look at this line. According to this line, no more than 2,000 toys will be sold every month. So if there are a total of X dolls and there are a total of Y toy cars, then the toys in total should not exceed 2,000. So we represent that as X plus Y is less than or equal to 2,000. Okay, next constraint is the store owner pays $8 and $14 for each 1 unit of doll and car respectively. However, the store owner does not plan to invest more than $20,000 in inventory of these toys. So if there are X dolls and there are Y toy cars, how much is the total cost spent by the store owner? In that case, the store owner will pay 8X plus 14Y. However, 8X plus 14Y should not exceed $20,000 because the store owner does not plan to invest more than $20,000. So we have the inequality 8x plus 14y is less than or equal to 20,000. So this completes the resource constraints. However, there are constraints that are not listed in the problem. Take note that X represents the number of dolls and Y represents the number of toy cars. So in this case, X and Y cannot have negative values. So we have to include the non-negativity constraints. So now we are done converting the word problem into a linear programming model. We can now begin solving the problem.